Okay, today we're going to talk about 9.4, solving equations by square rooting. Now, before we do that, though, we need to go over a rule. Now, we'll talk about it right now, but we'll get into better detail in class. And that is, if I have x squared, and if I take the square root of x squared, that will always equal the absolute value of x. Now, why is that? Quick explanation would be if I were to have a number, let's say the number 5, and I square it, that'd be 25. Square root it, that would be 5 again, which would be the same thing as basically taking 5 and doing the absolute value, which is 5 also. Same goes along with the negative number. If I were to take negative 5 squared is 25. Square root of 25 is 5. If I take the absolute value of negative 5, it's 5 as well. So these two things are equivalent, and this idea that the square root of x squared is equal to the absolute value of x is going to be really important to us. So let's talk about solving equations that involve by this method, square root method. So for instance, number 1, we have x squared equals 25. Well, that would be wonderful if it said x equals 25, but it doesn't. So what we can do is we can simply take the square root of both sides. Now the square root and squaring, as we talked about before, are inverses of each other. Now this part is really important. This, as we just wrote, is equal to this. So it'll be the absolute value of x equals the square root of 25 is 5. And now if you remember way back when we did absolute value equations, whenever we have an absolute value equation, something that's written like this, remember we have to account for the positive and the negative. So then my answer would be x is equal to the positive 5 and negative 5. And there we go. Get two answers, positive and negative 5. Both answers are extremely important, and this step right here is extremely important. Okay, easy enough. Let's move on to number 2. So x squared equals 14. Very simply, I'm going to square root both sides. Okay, x squared of x squared is equal to the absolute value of x. Now, square root of 14, we don't know what the square root of 14 is, but can you break down 14? Yeah, you could, which would be 7 and 2. But can you take the square root of 7 or 2? No, you cannot, so it'll just be the square root of 14. And what's the absolute value of x equal to the square root of 14? Well, that's just simply equal to x is equal to plus or minus root 14. There we go. Not terribly difficult so far. You should try number 3. If you can, hit pause, give it a shot. Okay, so here we go. I'm going to just square root both sides. This will be the absolute value of x. Now, what's the problem here? The problem is we have a negative inside of a radical. So this would be not possible, or no solution. And if you think about it, just think about the original problem. X squared equals a negative number. There's no way that you can square a number and come up with a negative value as an answer, so not possible. Okay, let's move down to number 4. A little bit different than the ones we've done before. You notice here that there's a 3 out here. Well, the basic rule here for this square root method is you want to get the x squared by itself first. So, very first thing is, I'm just going to divide both sides by 3. X squared equals 20. And then the next thing is to do like we did with the previous ones. And I'm going to square root. Square root of x squared is absolute value of x. Again, mandatory step right there. Square root of 20. Let's see, how does that break down? Well, I know that's 4 and 5. And I know the square root of 4 is 2, so it's 2 root 5. So x is going to equal plus or minus 2 root 5. Now, something that maybe you're thinking to yourself right now is, will this always be plus or minus in the same number? Actually, no. And we'll show you a few examples here in just a minute. So far, we've had nothing but that, plus or minus 5, plus or minus root 14. But this won't always just be plus or minus and then this same number right here. number 5. So again, general rule that we want to follow is we want to get the x squared by itself. So what's the first thing we could do? Well, we could simply add 81 to both sides. So 4x squared equals 81. Divide by 4. X squared equals, now 4 doesn't divide into 81. No big deal. So next step, like we've done all before, because we have the x squared by itself, we could square root. I'm going to move it up here. Now, so I get absolute value of x. Now, some of you might be sweating a little bit, and I was like, oh, geez, how do we square root a fraction? Well, remember, very easy. We're just simply going to square root the top. Square root of the square root of 81 is 9, and the square root of 4 is 2. That wasn't too difficult. And then, last but not least, x is equal to plus or minus 9 halves. Okay. All right, almost done. Last type of square root method problem. Okay, are these two right here. You notice here how these are different, that you have this whole quantity inside parentheses. This whole thing is being squared. Versus up over here, we didn't have the whole thing being squared, or there was just one term there. So when I have a problem like this, I'm still going to follow the first step that we did way up here. That is, the squared part was all by itself, so we just square rooted. Well, over here you notice the squared part, this whole thing, there's nothing else over there. So we can simply square root this whole thing. So I get the absolute value of x minus 3 equals 7. So this is going to equal plus or minus 7. Now that's not our answer, obviously. We have to actually come up with our solution. We've got to get x by itself. So what does that mean? So what that means is I'm going to get x minus 3 equals positive 7. And x minus 3 equals negative 7. You got to split it up and solve. So I'll just add 3. X equals 10. Add 3. X equals negative 4. So here's the example I was talking about just a few minutes ago, where we get two answers, but this time it's not just plus or minus like it was up here or any of these other ones. It's actually two different numbers. And if you were to plug this back in, plug 10 back in. 10 minus 3 is 7. 7 squared is 49. Plug this in. Negative 4 minus 3 is negative 7. Negative 7 squared is 49. So they both do work. Okay, last one. So if you understood that one, you should hit pause, give that one a shot, see if you come up with the right answer. Okay, here we go. So I'm going to square root both sides. So I get the absolute value of x plus 5 equals, now you can break down root 12. I can think of 4 and 3, so that'd be 2 root 3. So x plus 5 equals plus or minus 2 root 3. So that means x plus 5 equals positive 2 root 3, and x plus 5 equals negative 2 root 3. So last but not least, I'm going to subtract 5. Now, can you combine those? You have 2 root 3 minus 5? No, you can't. So you can just write your answer as 2 root 3 minus 5. Same thing over here, subtract 5. X equals negative 2 root 3 minus 5. And that's it. That's okay to have an answer that looks like that. Doesn't seem like it's complete, but it actually is. It's simplified as can be. Unless you use the calculator to approximate what 2 root 3 is, there's nothing else you can do. Okay, so let's just kind of recap here. First thing is this rule up here, obviously very important. We used it every single time. Square root of x squared is equal to absolute value of x. So the rule that we want to follow is get the x squared by itself, or the squared portion by itself, and then just square root. And then once I get down to this part, I got to make sure I account for the positive and the negative. So again, when we get down to here, you got to get the x squared part by itself, okay, and then square root. And then not always will we have answers that are always just plus or minus a certain number. Sometimes we'll actually get answers that are completely different than each other. Okay? Okay, hopefully that makes sense. As always, if you got questions, make sure you bring them to class. Okay, thank you.